The process for solving an exponential or a logarithmic equation is different depending on what the equation looks like. In example 1, solve 3 to the negative x equals 27 to the x plus 4. This equation can be solved only using properties of exponents because the numbers 3 and 27 can be written in terms of the same base, which is 3. So the left side of the equation already has a base of 3, so we can leave it as 3 to the negative x, but the right side we want to rewrite 27 as a base of 3. So we'll write 27 as 3 to the third power instead. So then we would have 3 to the negative x equals 3 to the 3 to the x plus 4 power. Let's rewrite this a little bit differently. Keep 3 to the negative x on the left side, and on the right side we'll write this as 3 to the 3 times x plus 4. The reason we write it that way is that the power of a power, the rule for exponents is that we multiply those two powers. Now that we have 3 raised to two different powers, we can set those two powers equal, because if 3 to something is equal to 3 to something else, then those two powers must be equal. So that means we set negative x equal to 3 times x plus 4. But we can only do this once we have the same base number, which in this case we have the same base number of 3. So we couldn't do this at the beginning when we had different base numbers of 3 and 27. And now this is just a linear equation that we can solve. So distribute 3 to get 3x plus 12. Move the x's to one side by subtracting them. Negative x minus 3x is negative 4x equals 12. And divide by negative 4 to get x equals negative 3. Let's just check that answer by plugging it back into the original for x. So plugging it in here, that would be 3 to the negative 3 equals 27 to the negative 3 plus 4. We're just doing this to check that this answer works. Negative 3 is positive 3, so that's really 3 to the third on the left. And then on the right we have 27 to the negative 3 plus 4 is 1. So now 3 to the third is 27. And 27 to the 1 is 27. So that answer, x equals negative 3, does work in this equation. Now if instead we have logarithms in the equation, one step to solving logarithmic equations, for example log of x plus log of x minus 9 equals 1, is to use log properties to first combine the logarithms. So here we have addition between two logarithms. That means we can multiply the numbers on the inside. So we can rewrite the left side as log of x multiplied by x minus 9. And then on the left side we still have 1. Now if the base of a logarithm is not written, that base is 10. So this is really log base 10 of x times x minus 9. Now let's change this into exponent form. So when we write it in exponent form, the base of the log 10 becomes the base of an exponent. So we get 10 raised to the power 1 is equal to the inside of the logarithm, which is x times x minus 9. Now let's simplify and solve this quadratic equation. Distribute the x to get x squared minus 9x equals 10 to the 1, which is 10. Now let's move the 10 over to the other side so that we have all terms on one side. To get 0 equals x squared minus 9x minus 10. To solve a quadratic, we could use the quadratic formula or factor. This is factorable. We look for a pair of numbers that multiplies to negative 10 that adds to negative 9. Those numbers are negative 10 and positive 1. So we get 0 equals x plus 1 multiplied by x minus 10. Last step for solving is to set each factor equal to 0. So set x plus 1 equal to 0. We would solve by subtracting 1 from both sides to get x equals negative 1. And then the other factor, x minus 10 equals 0. We solve by adding 10 to both sides to get x equals 10. And now let's check these two answers in the original equation. If we check first the answer x equals negative 1 into the original, we would get log of negative 1 plus log of negative 10 equals 1. However, the argument of a log must be not negative, so it actually must be greater than 0. So that means that neither of these options will work, and the solution x equals negative 1 is not a solution to this equation. Let's try the next one, x equals 10. Plugging into the original, that would be log of 10 plus log of 10 minus 9, which is 1, equal to 1. Log of 10 is 1. Log of 1 is 0. 1 plus 0 is indeed equal to 0. So this answer works, and our solution is x equals 10. It is important with logarithms especially to check the answers in the original equation to make sure that they work. It's also possible to solve an exponential equation using logarithms. For example, e to the 4x equals 6. Since 6 is not a power of e, because e is an irrational number, we could change this to logarithm form to solve. So changing it to logarithm form, the base e would become the base of the logarithm, so we would write log base e of the number 6 is equal to the exponent 4x. But now log base e really means the natural log, or ln, of 6 equals 4x. And then to solve for x, we would divide by 4 on both sides. To get x equals ln of 6 divided by 4, which is approximately 0.448. It is best with this type of problem where you have to use a calculator to calculate something like ln of 6 to wait till the very last step before rounding. So plug in exactly ln of 6 and then divide that number by 4 and then round.